Hello everyone, welcome to my channel Precision Manufacturing System. Today I'm going to explain about the UMESH subroutine. So after this video you will be able to write your own UMESHMOTION subroutine. In my previous video I explain about how to simulate wear simulation, so you can find my channel Precision Manufacturing System. After entering my channel you can find wear simulation, abaqus tutorial wear simulation with development ARCHARD model using UMESHMOTION Subroutine. In this video I explain how to simulate pin on disk simulation using ARCHARD model and utilizing UMESHMOTION subroutine. So please find this video in my channel and watch this video. After that you can get lots of information about wear simulation, but in this video I'm trying to explain how to write or prepare your own UMESHMOTION subroutine that's very practical in wear simulation. So as I said already, for my wear simulation I use ARCHARD model. In ARCHARD model we usually use load, normal load or pressure and sliding distance, and another one it's so important is wear coefficient that you can find it by experimental tests such as pin and disk test. And also you can see this equation. In this equation hj and hj minus 1 is related to delta h that show wear depths, and you can use this equation in your wear UMESHMOTION subroutine. As I told you, K is wear coefficient, P is your C press or contact pressure at that increment, and delta S is your sliding distance. As you can see in this figure, when we use UMESHMOTION subroutine during your wear simulation, after every pass the node move down. For example, like this picture, this is our old surface, and after the pass this is our new surface. In our new surface node move down, and based on your wear coefficient and pressure between for example your pin and the deformable plate, for example disk. And after that you can see this wear depths, and based on your information you provide in your UMESHMOTION subroutine. Maybe you know how to simulate for cold or warm, hot forging. In cold or hot forging, if we during simulation we don't use ALE adaptive mesh, it's not possible to finish your forging simulation, because you encounter large deformation and got error distortion error. So during that simulation, we usually use ALE adaptive mesh. In ALE adaptive mesh, cause during the deformation, large deformation element, some element remove and replace with new element, or modify the element shape. So during the wear simulation also we use ALE adaptive mesh combined with UMESHMOTION subroutine. And as I told already, in UMESHMOTION subroutine we use usually P, or in abaqus known as a cypress, or and delta S, or a sliding distance, and abaqus illustrate the sliding distance with C slip. And you abaqus or UMESHMOTION subroutine get information with the utility routines like get where or get that it's especially so difficult from UMESHMOTION. And then calculate the wear depths, as I told you, H or delta H, K or wear coefficient, and cypress or P average, and delta S or a sliding distance, C slip. You can see in this equation, and abaqus use this equation to calculate wear depths. And also during your UMESHMOTION we use also a local abaqus conventionally provide a local coordinate system called a local at each node that is calculated based on average of the local element surface orientation. In the following, I explain how to use a local in your UMESHMOTION subroutine. And this flowchart show how where simulation acted during your process. In abaqus, as I told you, we use in UMESHMOTION we use ARCHARD model, and this is the flowchart of where simulation using UMESHMOTION subroutine. In our model we usually provide geometry, material property, loads, boundary condition, contact definition. It's necessary to told you in abaqus for where simulation using UMESHMOTION subroutine, we usually use abaqus standard static. It's not possible for us. We use UMESHMOTION for dynamic simulation, so we use a static model, and we define contact pressure, surface, and nodal coordinate. Use UMESHMOTION subroutine, Fortran subroutine, define contact property, and after UMESHMOTION of the surface node, and also ALE adaptive meshing, and then calculate the wear increment, and repeat this flowchart to finish our model, our simulation. So now we start how to prepare our own UMESHMOTION subroutine. So we use Google and search abaqus document, abaqus, for example, abaqus document 2016 documentation. Okay, we refer to abaqus user subroutine reference guide. Okay, we use user subroutine and abaqus standard subroutine, and find UMESHMOTION subroutine. Okay, UMESHMOTION. Okay, This is UMESHMOTION Subroutine. You can find lots of information about UMESHMOTION Subroutine in this page. So for user subroutine, first we need to use this information in our UMESHMOTION subroutine, and also you can find something, for example, variable to be defined, for example, uLocal you need to define, and also this variable can be updated if you use in your UMESHMOTION. For example, smooth is related to ALE adaptive mesh, and also you can use by this variable you can get some a variable pass in for information, give you some information. And other thing, you can please study this page to get lots of information and start your UMESHMOTION subroutine. So at this time I open Notepad++. Okay, so I copy paste this one, Ctrl C and Ctrl V. So okay, so this is the information. As I told you, you need to get information about what is this. So as I told you, you need to study this page and get lots of information about which one do you need. And then okay, for UMESHMOTION we need to fill out some information in this section, user coding to define your local, and optionally, for example, get information about connectivity between node and element, and get information, material information, CPRS, CSLIP, and other things. So I delete this section and fill out by my information which we need for simulation. Okay, so for example, we can write some information here, and also write, for example, 1 here and 2 here. Is so important when you write something here. It's necessary to write after 1 and 2 to prevent error. So for example, I write here real, for example, real, and write, for example, CPRS and CSLIP and COpen and C-share, and DH, and for example kappa or kappa or where coefficient we need. And also here, for example, this is our part name, equal to CP name common where define I counter, counts the number of times that UMESHMOTION is consulted. Enter I counter equal I counter plus 1, and also we define LSMOS equal 1, define our kappa or wear coefficient. Kappa equal, for example, 4 a minus 9, and okay, so another one we need to define, as I told you, getting information from abaqus subroutine. So for example, J type equals 0 means node number as input. For example, if J type equal 1 means element number as input, so we choose 0 and the node selected as a input. If you want to choose the element as an input, you need to change this J type to 1. So I choose node, so J type must be 0. And now we want to get information, get part info. So we go in abaqus documentation. So we use utility routines and get obtain part info, open obtain part info, and choose this one, or this one is not important. Control C, we choose for example this one, Control C and Control V. By this comment we get information, part information, and enter. For example, we define LM CP name here, and LMs equal max, for example, maximum allowable length of GLMs, the array of element number for elements connected to node. So by using this info comment we get part information. Another one, another sub utility we need to use about retrieve elements connect to the node. Connectivity, define connectivity between node and element. So we use obtain node information, material point, obtain node to element connectivity. We use this comment for get element information about connectivity between node and elements. So I use this one, Control C, and Control V, and also okay, already we type G type equals 0, so we select node. And another one, we need to define contact stress and contact displacement, I mean C press and C sleep. Okay, so we go abaqus documentation page and choose obtain material point information. Okay, so we choose this command, Control C and Control V. Instead of where, we write C press or C sleep for contact stress or contact displacement. So we write C stress in this section to define C press and enter C press we call as an array 1. Okay, and you need to define another one, Control paste, and now instead of where, we write C this to get information about sliding distance, and write C sleep equal sqrt. I show you in my ppt file, array 1 okay plus array 3 2. Okay, sorry, this is array 2 because we choose C press as array 1. Okay, after get information, now we can define our ARCHARD model. So we write dh or delta h, we write already, and also I explained about it, and kappa multiply C press multiply C sleep. Okay, and then after that, this is our ARCHARD model we use, and also I explain about ARCHARD model equation in my ppt file. And now we define U local 3 means this is a 3D model, so we need to write 3. If we want to use for example 2D model, it's necessary to write 2. So you can get information in abaqus documentation. So you local 3 minus dh. Okay, dh, this is dh is related to where depth, so every in every pass this equation calculate the node movement. So this is u local the initial coordinate minus dh, so this one is the current node information. So after that you just write return to continue. Okay, it's not necessary to write here. Okay. So this is all information about how to write your UMESHMOTION subroutine and then use in your where simulation. You can find my where my previous video about where simulation, how to define other thing in abaqus CAE, and then use the UMESHMOTION subroutine to calculate your where depths. It's so easy if you follow my previous video and this video to define your own UMESHMOTION subroutine and also get information about all of the variable factor that's related to UMESHMOTION subroutine. So if you need any information, please send a message or send email to me, and I will answer your question as soon as possible. And also please don't forget to subscribe my channel. If you subscribe my channel, you don't lose anything, but just support us and increase my motivation to prepare more video about CAE simulation or other subroutine IMP file. Thank you so much for watching my video.